Okay, so open up your journals, please, to the notes section. And our learning goal today is slope-intercept form. Slope-intercept form. And today's date is 2/18/50. Slope-intercept form. And slope-intercept form refers to the form of an equation that you can graph. So the form is y equals mx plus b. And since we always try to tie new learning to old learning, some of these variables, if you're thinking about graphing, you already know. Who can tell me something you already know that's used up there, if you're thinking about graphing? Dominic?
Y.
Where would y be?
It'd be the vertical line in a graph.
The y-axis, okay, that's true. How about in this scenario? Where would the y be? Yeah, you're pointing to this side, right? Yeah, y, good. And then what would go here? X. So we know that in this scenario, the x and y are the x and y of an ordered pair. Okay, so now you already know what two of those variables mean. Does anybody remember m? We talked about what m was 2 days ago. Ellie, what do you think? Slope, good. So we know that m is slope. So that leaves us with the b, and the b is the y-intercept. Now Dominic just told us that the y is the axis that goes up and down, and the y-intercept is where the line goes through the axis. So for instance, if this is my coordinate plane, and I've got 1, 2, 3, 4, but my line goes right through here, that's the 2. So my y-intercept, my b, would be equal to 2. Does that make sense? And we use this a lot in order to graph. If I give you an equation that has a certain slope and a certain y-intercept, you can make the graph of the line without having to make a table, because you'll know the y-intercept and you'll know the slope. So slope-intercept form. Now I'd like you to turn in your packets, please, to lesson 9.5. It's on page 412. And go quicker. And we'll read the key concept in the center of the page here. Go ahead and read with me. The slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. So the symbols are y equals mx plus b. And then they're going to give us an example. If y equals 2x plus 1, we know the slope is 2 and the intercept is 1. So let's look at the screen and see what that did for us. Remembering that I said you could graph a line just based on this equation. So if you're looking here, I always start with my y-intercept. If my y-intercept's at 1, I know I'm going to put a point at the 1 on the y-intercept. Then I just have to figure out, well, where's the line going to go through that point? And my slope is 2, which means up 2 over 1 in a positive direction, because it's a positive 2. So let's see, if I go up 2, 1, 2 over 1, 1, 2 over 1. Then I can connect the points and have a slope of 2. Does that make sense? So just like counting on a graph to find slope is very easy, using this y-intercept form to be able to graph a line is also very easy, because you can just plug in the y-intercept and then find the slope. Okay, so we're going to look at the example 1 at the bottom. It says, state the slope and the y-intercept of y equals 1/4 x minus 6. So who wants to tell me what the slope is? Yes? 1/4, good. And what's the y-intercept? This one's a little tricky, Andrew. -6. And he did that just right. the sign is attached to the intercept. So if it was plus 6, we would know it'd be a positive 6. If it's minus 6, then it's negative 6. So there's two problems at the bottom, 1a and 1b. Go ahead and just write down what's the slope and what's the y-intercept. The way we'll do that is m equals and b equals. M equals and b equals. M being the slope and b the y-intercept. Put your pencil in the air when you're done. Okay, and Tatum, what did you get for slope on the first problem?
3,
And the y-intercept?
1,
Good. And on the second problem, let's go with Kyle. What did you get for slope?
-2.
And gosh, the y-intercept's a little tricky, right? Because it's not even there. What do we call something when it's not there, when it's nothing? What do you think saying when it's nothing?
Undefined.
No, this is defined. Yes. 1 is something. If I give you nothing, what do I give you? Yes. 0. Good. And that's a good thing to remember. So we could write this y equals negative 2x plus 0. Right? So what does that mean about the line? Where's it going to go through? Where's the intercept? Yes.
On the origin.
On the origin, which means it's directly proportional or a direct variation. Those two words mean the same thing and they're interchanged on your test. So here we go. Directly proportional or a direct variation. Both mean that it goes through the origin. Okay? Directly proportional to direct variation, both mean it goes through the origin. I have one that I'm going to try that's not in your packet. We'll call this 1C. What if we had y equals x plus 1? This is another one that's a little tricky. Go ahead and you can talk with your tables. What do you think the slope is and what do you think the y-intercept is? Who wants to try it? Yeah, what do you think? Well, if I had 0 times x, I'd get 0. So I have an x, so that can't be right. What do you think?
1.
1 times x will give me x. So that's exactly it. You have to remember that it's understood that there would be a 1 in front of it. So our slope is 1, and 1 is our y-intercept. Okay. What about if we had one more that looked like this? Y equals negative x plus 6. Find the slope and the y-intercept. What do you think, Robert?
M would be -1.
M would be -1. Correct. -1. And what's the y-intercept?
6.
6. Good. Okay. So I think we found all the possible variations there. The hardest thing, I think, to remember is what to do when there is no y-intercept. Means it goes to the origin. It'd be 0. And if it's just x or negative x, that would be either just 1 or -1 as a slope. Turning the page to example 2. Now, in this scenario, the problem is it's not in y equals mx plus b format. And so these we want to try to do some together. Go ahead and in your journal write down 6x plus y equals -3. Six x plus y equals -3. Now let's remember how we want this to look. We want it to look as y equals mx plus b. So we've got y on the right, the side we want it on, but this 6x we really want over here, don't we? So how can we get this over there? Who remembers from our algebra work? How can we get that moved? This is a positive, so what's the inverse operation going to be? Yeah. No, because it doesn't, there's no multiplication. We're going to have to maybe subtract from both sides, right? So 6x plus y minus 6x. Is that going to get rid of that 6x for us? Equals negative 3 minus 6x. So we can cancel both of these out, and we're left with y, which is what we wanted. Now we want it in this form, mx plus b. We're allowed to change the order of these two things as long as we keep the signs intact. So this is negative 6x minus 3. Now that you've got it in the right order, can you tell me what m and b are? Raise your hand when you know. Haley, what do you think?
The slope is 6 or -6.
Yeah, which one?
-6.
Negative 6, exactly. Good.
And then 3.
Yes, which one?
-3.
Negative 3, good. The signs must stay attached to the number that they're with, correct. So the slope would be negative 6 and the y-intercept would be negative 3. So we've now learned everything we need to know about slope-intercept form. We know how to find both slope and y-intercept, how to look at it on a graph, and we know how to take an equation that's not in y-intercept form and turn it into y-intercept form.